Welcome to the deep dive. Today we are tackling something really fundamental. It feels less like straight engineering and, well, more like geek philosophy, doesn't it?
He really does.
We're talking about how we give complex autonomous systems a sense of morality. Because as AI gets more autonomous, whether it's making those split-second decisions in traffic or much more complex choices about resources in hospitals, it's moving beyond just efficiency.
Right. It's stepping into genuine moral ambiguity.
And the core problem, really, is that the foundation AI is built on, things like standard decision theory.
Yeah.
They're designed for optimization.
Right, exactly. They're about reaching a goal, maximizing some kind of utility. They don't really have a built-in moral compass. They're essentially, well, morally blind agents just following a self-interest kind of rule.
So if we want general AI, we can't just keep adding specific rules for every single situation. That's just not scalable.
No, absolutely not. We need something more fundamental, a general framework, you could say, like a basic language of ethics that the AI can actually work with.
And that's exactly our mission for this deep dive. We want to explore two of the main roadmaps that researchers are actively working on right now to develop that kind of general moral framework.
Okay.
We're going to dig into extending game theory and also leveraging, well, the power of machine learning.
Two really interesting but quite different approaches.
Yeah. Now, when most people think about the stakes here, what usually comes to mind first is that classic, maybe a bit overused, self-driving car dilemma.
The trolley problem on wheels, essentially.
Right. The unavoidable crash. The car has to choose save the passenger or swerve and maybe hit a cyclist or, someone on the pavement. It's very clean, very visceral. Different choices, different impacts on different people.
And that thought experiment is important, for sparking the imagination. But it kind of makes it seem like this is all hypothetical, a problem for the future. What's really striking, and maybe a bit sobering, is that AI is already making these kinds of life or death moral judgment calls today.
Really? Like
Yeah.
what?
Well, think about resource allocation. We touched on this in the source material. There are algorithms developed within the AI community being used right now in complex kidney exchanges.
Kidney exchanges. Wow. How does that work?
It's fascinating, actually. They
Yep.
manage these huge multi-step swap networks. The goal is to maximize the total number of successful transplants across a large pool of incompatible donors and recipients.
So the algorithm decides who gets which kidney.
Essentially, yes. It has to weigh things like, okay, this patient is more urgent, maybe closer to death, but this other patient is a better tissue match, meaning a higher chance of the kidney lasting long term.
That's a direct moral calculation with immediate life or death
Yeah,
consequence.
that's happening right now. The stakes couldn't be higher, really.
And that really brings us to the why behind this whole deep dive, doesn't it? It's not just some academic puzzle.
Not at all.
If these autonomous systems are going to become a bigger part of society, coordinating infrastructure, helping with elder care, managing healthcare resources,
Or seems increasingly likely.
then they absolutely have to be safer, more robust, genuinely beneficial, and maybe this is the hardest part, morally acceptable to, well, pretty much everyone.
Right. If people find the AI's moral choices unpredictable or worse, repugnant, the adoption of the technology just stops dead in its tracks.
So the goal isn't just making AI smart.
No, it's about building in a level of moral consistency, predictability, something that earns the trust of the society it's supposed to serve. We're trying to formalize trust in a way.
Formalized trust, that's a great way to put it. Okay, so let's dive into the first big hurdle. Let's unpack this starting problem. Why can't we just use the simplest ethical calculation out there? The one most early AI research defaulted to.
You mean straightforward utilitarianism or consequentialism?
Exactly. The idea that the right action is the one that produces the greatest good for the greatest number. On paper, it seems efficient, calculable.
It seems scalable, which is attractive for AI, but it hits a wall very quickly. We call it the utilitarian trap.
Because it leads to these conclusions that just clash violently with our basic human moral intuitions.
Right. Think about that classic philosophy example again. The healthy patient who walks into a clinic for a checkup and happens to be a perfect tissue match for 5 other patients who desperately need organ transplants.
Okay.
A purely utilitarian calculation, just maximizing good outcomes, 5 lives saved versus 1 life lost, would seem to demand, well, harvesting the healthy patient's organs.
5 lives outweigh 1. Simple math.
Simple math, yes.
Yeah.
But that action feels profoundly wrong to almost everyone across cultures, across ethical systems.
It's considered immoral, abhorrent even.
Absolutely.
Yeah.
And that highlights this huge gap between that simple arithmetic and the way human moral reasoning actually works. It's much more complex, much more nuanced.
So what are these simple utilitarian models missing? What do moral philosophy and psychology tell us is crucial?
Well, several things. We aren't just utility calculators.
Yeah.
First, and this one is really tricky, there's the distinction between doing harm and merely allowing harm to happen.
Ah, the classic active versus passive distinction.
Precisely. In the trolley problem variations, actively pulling a lever to divert the train feels different, morally, than simply letting the train continue on its original path, even if the outcome in terms of lives lost is identical. Simple math misses that entirely.
And then there's the whole issue of the agent's internal state.
Yeah.
Intent.
Yes. Intent is huge. We judge someone who meant to cause harm completely differently from someone whose actions accidentally caused harm as an unavoidable side effect of trying to do something good.
But how do you even begin to quantify intent for an AI? That feels incredibly difficult. It's subjective, internal.
It's a massive challenge for representation. And then there are the general rules we rely on.
Like don't kill, don't steal.
Exactly. Basic prohibitions, keep your promises. We don't usually run a full cost-benefit analysis of telling a small lie. We operate based on the general principle that honesty is right.
And finally, maybe the most fundamental things. Concepts like rights and roles.
Right. The patient's right to bodily autonomy, their right not to be treated merely as a means to an end. And the doctor's specific professional role, their duty is to this patient, overriding some abstract calculation of general public good.
Okay, this list, doing versus allowing, intent, rules, rights, roles, it sounds like we're trying to write, I don't know, a mathematical formula for the human soul or something.
It can feel that way.
It's a massive data science problem, isn't it? How do we take these, frankly, quite vague philosophical ideas and translate them into something concrete, something an AI can actually execute?
And that brings us right to the core challenge, the need for operationalizing ethics for AI.
Making it workable, computable.
Precisely. If a machine is going to use an ethical framework, that framework can't just offer fuzzy criteria like be fair or respect rights. It needs to be operationalizable, formal.
And probably quantitative, right? It needs numbers, it can crunch.
Presumably, yes. It needs to specify which actions are right or wrong across a huge variety of situations and likely how right or wrong they are.
Which means you need a really precise language.
Absolutely.
Yeah.
A formal language to represent, first, the structure of the actions themselves, like, was this action an intended means to a goal or just a side effect?
Yeah.
And second, it needs to represent all the morally relevant features of the situation and how they interact.
You need to be able to define the input features that make one action altruistic and another structurally similar action a betrayal.
Exactly. The inputs have to be clean, formalized, machine-readable. You can't just feed it a philosophical essay.
Okay, so if simple utility math fails us, the first major roadmap we're looking at turns to a framework that's already built for handling complex interactions. Game theory. I can see the appeal. It's designed for multi-agent scenarios, right?
It is. It's a natural starting point for modeling interactions where you have different parties with potentially conflicting interests. Game theory gives us representation tools like the extensive form of the game tree to map out sequences of actions, responses, and the final payoffs.
It provides a language for interaction over time.
That's right.
But wait. Game theory at its core is usually built on the idea of rational actors maximizing their own self-interest, doesn't it?
Typically, yes. That's the standard assumption.
Doesn't that clash fundamentally with morality, which often involves, self-sacrifice or considering others?
It clashes completely. And that clash is perfectly shown by a very simple but elegant experiment called the trust game. It really highlights where standard game theory just misses the boat on human moral behavior.
Okay, let's walk through the trust game setup again, because the details matter here.
Sure. So player one gets a sum of money, say $100. They can keep it all, or they can choose to give some fraction of it back to the experimenter.
Okay.
Whatever amount player one gives back, the experimenter triples it and gives that larger amount to player two.
Ah, so there's a potential for mutual gain here.
Exactly. Then, player two looks at the money they received and decides how much, if any, to return to player one.
Okay, simple setup. Now, what does standard self-interested game theory predict will happen?
If you apply the standard analysis method, which is called backward induction, basically reasoning from the end of the game backwards.
Right, figure out the last move first.
It predicts total selfishness. Player two, at the very last step, wants to maximize their own money. Regardless of how much they received, the rational move is to return exactly $0 to player 1.
Makes sense from a purely selfish viewpoint.
And player 1, assuming they're rational and no player 2 is also rational and selfish, will anticipate this.
So player 1 thinks, why would I give them anything if they're just going to keep it all?
Precisely. So player 1's best move, anticipating player 2 returning 0, is to give 0 in the first place. Keep the whole $100.
So the standard game theory prediction, the technical term is subgame perfect Nash equilibrium, is that no money changes hands at all.
Correct. 0 interaction, 0 trust, 0 gain.
But that's not what happens when you run this with real people, is it?
Not even close. Experiments consistently show that humans deviate massively from this prediction. People generally do give money.
They trust.
They do. Player 1 might risk, say, $50. The experimenter triples it, so player 2 gets $150. And very often, player 2 does return a significant portion, maybe $75, back to player 1.
So both players end up better off than the purely rational prediction. The benefit is created and shared.
Exactly. It defies the strict self-interest model.
Why? What's driving that difference?
The key insight is that human moral reasoning isn't just forward-looking, calculating future payoffs. It looks backward. It considers the context and the history of play.
So it matters how player 2 got the money.
Immensely. If player 1 showed trust by sending money, and player 2 keeps it all, player 2's action isn't just seen as selfish in a vacuum, it's judged morally.
It's seen as what? Ungrateful.
Ungrateful, exactly. Or unfair, or a betrayal of the trust player 1 placed in them. It violates an implied social contract. Standard game theory is blind to that history. It only sees the fertile payoffs. It can't capture that judgment of ungratefulness.
So simply tweaking the utility function to say, I care a little bit about the other person's payoff, pure altruism isn't enough.
It's insufficient. Because the moral judgment, whether player 2's action is okay or not, depends explicitly on what player 1 did before. It depends on the history.
Which means we need totally new kinds of solution concepts for these games. Moral solution concepts.
That's the idea. We need concepts sophisticated enough to weave that historical context into the decision-making process itself.
So analyzing the game isn't just about finding the equilibrium anymore. It's got to be tied up with figuring out if an agent morally should care about another agent's outcome given what's already happened.
Exactly. It's not just will they cooperate, but should they, based on past actions like trust or betrayal. That sounds like a huge shift in how you'd even set up the problem mathematically.
How do people try to do that? Is there a technical approach?
There is. Some important research, like the work by Letchford and colleagues back in 2008, proposed a mechanism. Their idea involves repeatedly solving the game, but, and this is the crucial part, modifying the agent's preferences based on the history of play before each step.
Modifying preferences? How does that work mechanically?
Okay, so in classical game theory, player 2 just has a utility function, let's call it U2, that simply aims to maximize their own monetary payoff, M2.
Simple enough, U2 x M2.
Right. In the moral solution concept, you change that function. You alter U2 to reflect moral factors like gratitude or reciprocity. Letchford et al. Introduced constraints based on that history of trust.
So what does the constraint look like for player 2 in the trust game?
Essentially, it builds in a penalty. If player 1 showed trust by sending money initially, player 2's modified utility function now gets a negative hit if they fail to reciprocate adequately.
So being ungrateful literally lowers their score.
Precisely. Specifically, the modified utility might require player 2 to ensure player 1 gets back at least what player 1 initially sent, unless doing so would drop player 2's own payoff below some minimum threshold they'd already secured in prior steps of reasoning.
Okay, so it's like encoding a fairness principle directly into the definition of rationality for that player, conditional on past actions.
You got it. The system mathematically encourages honoring the trust, because the utility function itself now prefers fairness or reciprocity, making it rational in this modified sense to return some money.
That pushes the theoretical outcome much closer to what we actually see humans do.
Dramatically closer. It's a powerful idea.
Yeah.
Embedding morality not as an external rule, but by changing the very definition of what the agent wants.
Okay, so let's say we manage to update the solution concepts in game theory to account for things like history and reciprocity. That seems like a big step forward.
It is, conceptually.
But then we hit another fundamental problem, right? The representation itself. The game tree. If the way we draw the game doesn't capture some morally relevant feature, the AI can't reason about it, no matter how clever the solution concept is.
Exactly. Garbage in, garbage out, morally speaking. If the feature isn't represented in the input data, the algorithm can't use it.
And this brings us back to that tricky distinction between doing versus allowing harm. Standard game theory struggles with this because it usually just looks at the final outcome state, not how you got there.
Right. Let's revisit that runaway train scenario. Train's heading towards player 2. Player 1 can switch it to another track where it will hit player 3 instead. 2 options: switch or do nothing.
Okay.
Now, if we draw this as a standard game tree, focusing only on payoffs, say, Mengele 100 for loss of life, 0 otherwise.
The outcomes look symmetrical, don't they?
Completely symmetrical in terms of the payoff numbers. If P1 does nothing, the payoff vector is maybe P1, 0, P2, Mengele 100, P3. If P1 switches, it's P1, 0, P2, 0, P3, negative 100.
One person dies in either case. The magnitude of loss is the same, just shifted between P2 and P3.
So the standard representation just sees 2 equivalent outcomes. It has absolutely no way to capture the moral difference most people feel between actively causing P3's death by switching the track versus passively allowing P2's existing danger to play out.
So the representation itself fails to capture the moral core of the dilemma. How do researchers propose fixing that?
The main proposal is to extend the representation scheme itself. Conceptually, it's straightforward. At each decision node in the game tree, you explicitly add a label to one specific action, the passive action.
So in the train case, do nothing gets the label passive.
Exactly. By adding this passive tag as a feature of the action itself, the AI now has something concrete it can reason about. It can be programmed with rules like avoid active harm, even if passive harm leads to an equivalent outcome, because it can now see the difference between the active and passive options in its representation.
Okay, that makes sense, adding a label, but isn't that just sort of coding the answer in beforehand? What if the situation changes?
That's a really sharp point.
What if being passive is the morally wrong thing, like failing to warn someone of danger when you easily could? Isn't inaction sometimes culpable?
Absolutely. That's a major challenge to this simple labeling fix. It only works if we assume passivity is generally morally preferable or neutral compared to action.
Which isn't always true.
No. If the context involves, say, a duty of care, like a doctor failing to treat a patient or a lifeguard ignoring a swimmer, then inaction becomes a serious moral failure. That simple binary passive label breaks down.
So you need even more extensions.
You'd need to extend the representation further to include the agent's contextual role, doctor, lifeguard, bystander, to properly weigh the moral significance of the passive choice in that specific situation.
Wow, okay. The representation keeps getting more complex. What about factors totally outside the immediate actions in the game, like what someone deserves?
Right, the concept of desert. If someone's moral status or what they deserve is based on things they did before this specific game even started.
Like, if player 3 is a known dangerous criminal and player 2 is an innocent child, does that change the train dilemma? Many people would say yes.
It certainly complicates the moral intuition. But if that prior status criminal versus child isn't included as a feature in the representation of the current game state, the AI can't possibly factor it in. It's reasoning in a moral vacuum, divorced from relevant history or character.
This all seems to point towards a really deep tension here. We're trying to get AI to make moral judgments that align with human ones.
That's all for the goal, yes.
But human judgment is, well, it's notoriously inconsistent. We're swayed by how things are presented, these things called framing effects.
Ah, yes. Kahneman and Tversky's work. This is maybe the most profound philosophical hurdle for the whole enterprise.
Can you remind us how framing effects work?
Sure. Their research, and lots since, show that how you describe a choice, the language you use, the context, the order you present options, can drastically change people's decisions, even if the underlying facts and probabilities are identical.
Like the classic example, a medical treatment described as having a 90% survival rate is perceived much more favorably than the exact same treatment described as having a 10% mortality rate.
Exactly. Logically identical, psychologically worlds apart. And this absolutely applies to moral dilemmas too. How you frame the trolley problem, for instance, can shift people's judgments.
So, here's the dilemma for AI morality, right? If we train an AI on human judgments, it's going to learn these biases, these framing effects.
It likely will, yes.
So what's the goal then? Do we want an AI that perfectly mirrors human moral judgment, including all its inconsistencies and sensitivity to framing? a purely descriptive model.
That's one possibility, to build an AI that feels familiar because it makes judgments, even flawed ones like we do. But that's incredibly hard. It would need to understand the nuances of natural language framing, which is a whole other AI challenge.
Or do we want an AI that makes coherent, logically consistent moral judgments, even if they sometimes diverge from gut feelings? A prescriptive model of ideal morality, one that actively avoids framing effects.
That's the other path,
Yeah.
aiming for ethical rigor and consistency. But the risk there is that the AI's judgments might seem cold, alien, or just plain wrong compared to human intuition, leading to rejection.
So it's a choice between building an imperfect mirror of ourselves, warts and all, that people might accept because it's familiar.
Or building a potentially more rational, but perhaps less relatable, moral reasoner.
That choice seems fundamental. It really dictates the whole design philosophy.
It absolutely does. Descriptive versus prescriptive. Psychological familiarity versus logical consistency. It's a tension you can't easily escape when you're using human data to try and build moral machines. Okay, so given those representational challenges in game theory, trying to explicitly define all the rules and features up front.
Which seems incredibly hard.
The second major roadmap takes a very different tack. It looks to the power of machine learning to generalize from data.
So instead of top-down rules, this is more bottom-up, learning from examples.
Exactly. The basic idea is collect a large data set of moral dilemmas. Get human judges to label the decisions in these dilemmas as morally right, wrong, or maybe on a scale.
Okay, create a big training set of moral judgments.
Right. And then you train a sophisticated machine learning classifier on this data. The hope is that the classifier can learn the underlying patterns and generalize to new, unseen dilemmas.
So it's not about explicitly programming "don't betray trust." It's about showing the machine thousands of examples where trust was honored or betrayed and letting it figure out the pattern associated with wrongness.
That's the core idea. But just like with game theory, the ML system can't just read stories. Natural language descriptions are too messy.
It needs structured input, right? Features.
Precisely. The dilemmas have to be represented by their key moral features. We're back to needing a formal representation, but this time it's geared towards feeding a learning algorithm. The input needs to be a structured feature, vector, numbers the algorithm can process.
And these features can start out being specific to the domain.
They often do. Like we mentioned, for kidney allocation, features could be very technical. Probability of the graft surviving 5 years, the patient's waiting time, maybe a score for medical urgency.
Makes sense. For a self-driving car, maybe its expected number of fatalities, pedestrians involved, passengers involved, maybe who was legally at fault for the situation.
Exactly. Domain-specific features are often the starting point. But even there, deciding on the features gets morally tricky very fast.
How so?
Well, take the kidney example again. Should a patient's history of non-compliance with past medical advice be a negative feature in the allocation algorithm? Does that reduce their deservingness?
Oof, that's controversial.
Highly. Or is it morally relevant if one potential recipient recently donated $1 million to the hospital's research wing? Should that give them an edge?
Most people would say absolutely not, but you need to explicitly decide not to include that feature.
Exactly. Defining the feature set is making moral choices. The real holy grail here, the primary goal of this ML roadmap, isn't just domain-specific models. It's identifying abstract features that apply across different domains.
Moral primitives, things like harm or fairness that work whether you're talking cars or kidneys or, I don't know, financial advice.
That's the ambition. To find features that allow for building truly general moral AI, not just a collection of specialized ethicists.
Where do researchers look for these general, abstract features?
They turn directly to the fields that study human morality. Moral psychology and moral philosophy.
Okay.
For moral psychology, there's influential work like moral foundations theory, associated with Jonathan Haidt and others. They identified a set of basic, arguably cross-cultural moral foundations.
I think I've heard of these. Harm care? Fairness, reciprocity?
Those are the big two, yes.
Okay.
But also things like loyalty betrayal, authority subversion, and sanctity degradation or purity. Research continues to refine and debate these, but they provide a starting vocabulary.
So these aren't just vague concepts anymore. In the ML context, they become dimensions.
Exactly. They become measurable dimensions in the feature vector. The AI isn't reading a story, it's seeing a vector like harm potential. Point 8, fairness violation. Point 1, loyalty demand. Point 6, authority challenge. Point 2, it learns how combinations of scores on these dimensions correlate with human judgments of right and wrong.
So the ML system learns the function mapping these abstract feature vectors onto the moral labels provided by humans.
Precisely. And moral philosophy provides another source for these features, often with more fine-grained distinctions.
Like who?
Thinkers like Bernard Goethe, for example, compiled detailed lists of morally relevant features, things like causing death, causing pain, causing disability, depriving freedom, depriving pleasure, breaking promises, cheating, deceiving.
A whole taxonomy of harms and violations.
Right. The challenge is always translating these philosophical concepts into quantifiable attributes the machine can actually process and learn weights for. How much deception is involved here on a scale of 0 to 1?
That sounds like a huge task in itself. Okay, so you have the features, you have the human labels, the ML system learns to classify right, wrong.
Or it could learn something more nuanced.
Yeah.
Maybe a quantitative score. How wrong is this action on a scale of 1 to 10? That would use regression instead of classification. Or perhaps a probabilistic assessment. What's the likelihood this action violates the fairness principle given these features?
More nuance seems better. But classification or regression, that's only part of the story, isn't it? There's a massive requirement in ethics for interpretability.
Oh, absolutely crucial. Non-negotiable, really, especially in high-stakes domains. People like Anderson and Anderson pointed this out early on.
Why is it so critical?
Because in ethics, it's not enough just to do the right thing. We value the ability to explain why an action is right. We need justification, accountability.
And if the AI is just a black box, like a super complex deep neural network that spits out turn left but can't explain its moral reasoning.
That's unacceptable. Society can't trust it. If an AI denies someone a loan or recommends a parole decision or makes a medical choice, we need to know the principles it followed. Was it purely maximizing utility? Did it consider fairness? Rights? If it can't articulate its reasoning, it seems arbitrary, potentially unethical.
So the demand for interpretability pushes researchers towards certain types of ML models.
It definitely does. It often steers them away from the most complex, opaque models, even if they offer slightly higher accuracy, towards models that are inherently more transparent.
Like what? Decision trees. Rule-based systems.
Exactly. Models where you can actually trace the logic and see which features drove the decision. There's often a trade-off, maybe a slight hit in predictive power, for a huge gain in ethical explainability and trustworthiness.
Okay, so we've dug into these two big paradigms. On one hand, game theory, trying to extend rational solution concepts in a top-down way.
Right, focusing on formal structure and rules.
And on the other, machine learning, working bottom-up, generalizing from lots of human-labeled examples.
Learning patterns from data.
What's really interesting now is thinking about how these aren't necessarily opposing camps. Researchers are looking at ways to bring them together, right?
Absolutely. They can be highly complementary. It's not an either-or situation.
How does that work? How can they feed into each other?
Well, think about it this way. The game theory approach, with its focus on formal principles like reciprocity or distinguishing doing versus allowing, can provide high-quality, structured input for the machine learning system.
So the output of a moral game theory analysis, like this action violates the reciprocity constraint, could become a really informative feature fed into the ML classifier.
Precisely. It's like giving the ML system input from a philosophy expert alongside the raw human judgments. It anchors the learning process in established ethical concepts.
That makes sense. It gives the ML more structure. Does the feedback loop work the other way too?
They can, yes. Imagine the ML system, after analyzing thousands of diverse dilemmas, keeps finding that a certain subtle configuration of features, maybe something about conflicting loyalties in team settings, consistently predicts human moral discomfort, even though it's not explicitly captured in current game theoretic models.
So ML discovery flags a gap in the formal theory.
Exactly. It tells the game theorist, hey, your formal model is missing something important that consistently matters to human judges. That insight can then drive the refinement of the game theory representation or solution concepts, making them more comprehensive.
So they can iteratively improve each other. The theory provides structure for the learning, and the learning identifies gaps in the theory.
That's the potential synergy.
Now, this whole project, especially the ML part, relying on human data, raises a really big, maybe skeptical question.
I think I know where you're going.
If we're learning from humans, aren't we fundamentally limited? Can the AI ever be morally better than the humans providing the data? Or is the ceiling just human-level morality flaws and all?
That's the core skepticism, and it's a valid concern. But the source material offers two really interesting counter-arguments that suggest we might be able to move beyond just mirroring average human morality.
What's the first one?
The first is aggregation.
Aggregation, meaning just averaging judgments.
More sophisticated than simple averaging. Think about it. If you collect moral judgments from thousands of people, you're going to get noise. You'll get individual biases. Maybe someone misunderstood the dilemma. Maybe someone had a bad day. Idiosyncratic errors.
Sure, human judgment isn't perfect.
Right. But by using techniques from a field called computational social choice.
Computational social choice. Okay, what is that exactly?
It's essentially the study of collective decision-making, often drawing from voting theory. How do you combine diverse, potentially conflicting individual preferences or judgments into a single, sensible, collective choice?
So, applying voting methods to moral dilemmas.
Kind of, yeah. Imagine each human label on a dilemma as a vote. CSS provides mathematical procedures, things more complex than simple majority rule, like rank order methods or ways to find consensus to aggregate these individual judgments in a way that filters out the random noise and individual errors.
So the AI isn't learning the average judgment, it's learning a sort of statistically purified, more reliable consensus judgment.
Exactly. The resulting system might actually disagree with some of the individual human labels it was trained on, because the aggregation process has identified those labels as likely outliers or errors when viewed against the backdrop of the collective wisdom.
So aggregation could lead to a system that's more robust and potentially makes fewer idiosyncratic moral mistakes than any single human would.
That's the argument. It moves beyond mimicking any single person towards reflecting a more coherent, statistically grounded version of collective human morality.
Okay, that's one way AI could potentially improve on individual humans. What's the second argument?
The second one is even more ambitious, I think. It's the idea of discovery.
Discovery. Like the AI discovers new moral truths.
Potentially, yes.
Yeah.
Remember, machine learning isn't just about memorizing examples. It excels at finding subtle, complex patterns in data that humans might miss. So an ML system trained on vast amounts of dilemma data, represented by those abstract features like harm, fairness, loyalty. It might identify a deep underlying principle or a consistent relationship between these features that connects seemingly disparate moral situations.
A pattern we haven't consciously articulated.
Exactly. We might have strong intuitions about why action A in a self-driving car case is wrong and why action B in a medical allocation case is also wrong, but we might struggle to explain the common ethical thread linking them.
But the ML system, crunching the numbers on those abstract features, might find that thread.
It might find a unifying mathematical relationship. Whenever features X, Y, and Z align in this specific way, human judges consistently label the outcome as morally problematic, regardless of the surface details.
And if these newly discovered principles are robust, verifiable, maybe even help resolve inconsistencies in our own ethical theories,
then they could be articulated and fed back to humans. The AI could potentially help us refine our own moral understanding, point out blind spots or inconsistencies in our inherited ethics.
Wow. So the tool we build to encode our morality might end up teaching us how to be more moral.
That's the profound long-term potential, a kind of coevolution, where AI acts as a catalyst for improving human ethical reasoning itself.
Okay, that's definitely looking far ahead. For now, we need to stay grounded, right?
Absolutely. We have to be realistic. These moral AI systems are truly in their infancy. Just getting to a point where we have automated systems that consistently make moral decisions at a level broadly comparable to competent ethical humans, that would be a monumental achievement for the near future.
It requires blending really deep philosophical thinking with some very challenging technical work.
A true interdisciplinary challenge.
Well, this has been an incredibly rich deep dive. We've covered a lot of ground. We saw why simple consequentialism just doesn't cut it for AI morality.
The utilitarian trap.
Then we explored how researchers are trying to extend game theory's solution concepts to capture crucial things like history and reciprocity, while also grappling with the huge challenge of representing moral features like doing versus allowing or desert.
Right, the top-down, rule-based approach.
And then we looked at the machine learning roadmap, using human judgments to train systems to generalize, focusing on identifying abstract moral features drawn from psychology and philosophy, but facing the critical hurdle of interpretability.
The bottom-up, data-driven approach needing explainability.
Both showing real promise, especially maybe in combination, for building that foundational general moral language we need for autonomous systems.
That's a fascinating frontier.
So we'll leave you, our listeners, with a final thought to chew on, building on that idea of discovery we just discussed.
Okay.
If an AI system, through aggregation and pattern discovery, genuinely identifies new, coherent ethical principles that seem to resolve long-standing debates or inconsistencies in human moral philosophy, if it finds, say, a consistent mathematical way to balance duties and consequences that escapes our current philosophical tangles. Should we then start to see these machines not just as tools reflecting our values, but maybe, just maybe, as potential partners in ethical discovery? Could our machines eventually help guide humanity towards greater moral coherence?
Could AI become the next great ethical philosopher?
That's definitely something worth thinking about.